Right, this video basically is just about one of the conductive plastics that I make. It's a plastic that it's a recycled plastic. It's a plastic that I've used for lots and lots of different things, for pouring into moulds to make basic shapes of things. I use it as a conductive plastic. I use it as a binder. It binds to most surfaces. It's flexible, and it is very conductive. I'm working with other plastics as well. I'm trying to make, at the moment, porous plastics for some anode and cathode work. There's nothing to show there yet because I haven't yet achieved a plastic that's as porous as I want it to be. So obviously there's no point in discussing that in this video. But this plastic, as I say, it's recycled. I'm going to start backwards, if you like. What I'm going to show is the material itself that's already mixed and that's already been poured, and I'll show some measurements and stuff like that, and then sort of show you how it's made, or how I make it. It is so simple. It is such a simple thing to make, and it's probably worthy of a video, because as I say, I use it as a binder as well, a conductive binder. So yeah, what I'll do is I'll move the camera onto the bench, not the bench as you see it now, obviously, because it's a bit messy, but I'll have a tidy up, and then we'll go again and make a video.
Okay then, what we've got here obviously is the meter set on 200 ohms. This is some of the plastic that I poured earlier. It's only about 3 hours old, but if I press on that, you can see, definitely see my thumbprint. Now that, with the thickness of that, it needs about 12 hours to set. But I also put a piece on this, which is this is titanium, and that one is actually dry. So I did try it earlier on. I'll just run through it again and we'll see what the readings are. Now that piece there is 14-15 ohms. It's not quite dry, but if I find a piece that is, you get 0.4 of an ohm. Obviously this is thicker on one side than the other, so I just poured a bit on, that's all. Now again, that is 0.5 of an ohm, 0.4, and that's at half a centimetre. If I move to a centimetre, we've still got 0.4, 0.5 of an ohm. I don't know if you can actually see that. Okay, if I do it this way around then you can find the same spot. So that's at 1 centimetre, which is pretty good, really. I mean, for the graphite itself was a cheapy graphite. I think it was one of these ones that they use for lubrication and stuff like that. I don't really know what the micron size is or the mesh size is or anything, but I've got a feeling it's about maybe 50 micron or something like that. It's not, I don't think it's a regular or a good quality flake graphite or anything like that. So I mean, that's that piece there. Obviously this one, what I did, I just used some of this double-sided sticky tape and just made a mould and cast that into the mould. So we really do need to wait until that one is dry. Obviously I etched the aluminium as well. Now this one, if we go from graphite to the actual metal itself, it's the same resistance. Now, just in case you can't see that, and there we go, that's at 2 centimeters. So that's the plastic on there. This one I don't think we're going to get a reading because it is just way too soft at the moment, but I'll try it. Okay, so that was right on the edge there. Obviously that's going to be a bit drier on the edge, so that's that. Fairly good readings, you know, can't argue with that. In fact, if I were to try, I've got a piece of graphite here. .6. Now that's a piece of graphite, so we can't really argue with that. Now this particular plastic I've not only used to make obviously items in plastic with it, I've used it as a binder, and it's a phenomenal binder, and with readings like that you can see that it does make for a phenomenal binder as well. Now obviously you've got to readjust what you're doing if you're using it as a binder, and you want it very, very conductive. So again, you've got to, you know, you want your electrolyte to seep into it and stuff like that. So that's that anyway. So what I'll do now is I'll just move on to the next step and show you what it's made from. Just before I go any further with that, here's the rest of that plastic with the graphite in it, and it's on my stirrer, and you can see it there stirring away in the background. Okay, so you need, well, you don't particularly need a stirrer, but it helps. Now you need 1, 2, 3, 4 components for this basically, and what I've got in here in this tub is a load of this. Polystyrene. Now you've all seen the YouTube videos where you can dissolve the polystyrene with acetone, and that's how I've done this. And what I've got here basically is a big old tub of just that polystyrene in acetone. Now I won't leave the lid off this for too long because acetone does evaporate fairly quickly. Now the amounts you need to play with yourself. What I'm going to do is I'm going to take just a spoonful of that, which is the polystyrene dissolved in acetone. I'm going to put that in there and get this lid back on really quickly. Old Langage Farm ice cream factory tub, look, beautiful ice cream. You'll know that one if you live anywhere near Devon. Okay, so that's that. Now the other thing you need, obviously that is unusable as it is, so you need a carrier or another solvent, and the other solvent is not acetone. It's not ethyl acetate, it is toluene. Okay, so that's the one I use for this. Now again, it doesn't really matter how much of that you put in there, unless you put too little in, which is no good at all. So what you've got to do, you see it's quite gloopy initially, but what you need to do is get all that off your spoon and stir it. and it will dissipate into the toluene. Now the reason I had mine on a stirrer was because if you don't do it that way, if you just continue to mix it like this, you'll just get loads and loads of bubbles in it, big air bubbles in it. Now you've got to leave it to stand for hours then to get these air bubbles out, or vacuum it, whichever. Now you can see that is dissipating into the toluene, and I've got a few other black specks in there that I didn't want, but there you go. So we do that, and it takes quite a while to stir this in. This is why I've got mine on a stirrer. So if I pop a stir bar into there and put that on the stirrer, I'll move the camera. Okay, so there's that stuff I've just mixed there, the plastic, shall we say, because it is a plastic, and it's stirring away quite merrily. Realistically, you need it to be at least 10 mil above that stir bar, because as it is now, it's going to be pulling air into it, and with it above, it won't pull so much air into it. But the other thing you need to do now is cover that, because that toluene will evaporate. I've got myself an elastic band and some cling film. Now I'm going to just leave that stirring away there for about 15-20 minutes to make sure that that is fully dissipated into that toluene. I mean, there are going to be lots of other solvents out there that you can use. I've tried one or two, but I found, you know, for my purposes, toluene is the best. Now there's going to be other solvents out there that will evaporate more quickly than toluene. So when you've cast the material, it'll dry a lot quicker, but you know, toluene is the one for me, so that's what I'm using. Okay, so there's my mix. Look, it's quite viscous, nice and runny, nice and pourable, nice and castable. So that's that. Ideally, rather than use a beaker, if you can do this in a jar that you can put a lid on, even better, because all of this stuff that's around the edge of the jar, you've got a devil's own job to get it off if you let it dry. Now that has dried. Now it's only 3 hours old, but I know once that's 24 hours old, you've got devil's own job to get that off. It really is. It makes a good bond onto most surfaces. Well, I mean, that's glass, so you know, you've got to be careful with that one, because the last time I made this in a beaker and left it in a beaker like this with an elastic band on the top, that stuff that was on the side dried, and it took me hours to get it off. So there's a good one to remember. I'm just going to pop an elastic band on that before that starts to evaporate. That's the other thing, you can't leave it like that. You need to get it in a jar with a proper sealed lid, because that will still evaporate like that, believe it or not. It just finds a way, you know, it's solvent. So that's that. Now this spoon I've used, it's drying already on there, look, you know, and that's been a few minutes literally. So obviously if you cast it nice and thin like I did there on that metal, it will dry fairly quickly, although that's over 3 hours old, just over 3 hours old now. That still isn't properly dry, but we've managed to get a reading from it. You know, I'm just, as usual, I'm just rushing the job, so there you go. So the next step now is to get some graphite into it. Now, as I say, my regular graphite that I would use would be a 4 micron flake graphite, good quality, but unfortunately I've used it all for making graphene oxide. I'm just waiting for some more to come. But you know, the sooner this stuff's gone the better really, because it's not brilliant. So that's that. So now, as far as a mix ratio is concerned, I've found that roughly a 50-50 mix is good enough. Now you can do all sorts, you can weigh it, you can do whatever you like, you know, it's up to you to have a play and do what you think, do it the way you think you want to do it, for whatever properties you want. But what I'm going to do is I'm going to put 1 heaped spoon of the graphite in there, and I'm going to give that a quick manual stir just to get that graphite into that plastic. Now that is roughly the same mix. What I'm going to do is just put another 1/4 of a spoon in there, because it's not going to hurt. If you go too thick, then you've got to do this manually. You've got no choice, and it won't be as pourable obviously, but you just get it to the right consistency really. So it just dribbles off like that, and that's good enough. Now again, I'm just going to pop that on the stirrer. And I will move the camera, and there it is, merrily stirring away. Now you don't need to leave that on there for too long. I left the other one on for half an hour, I think, something like that. You know, I suppose 15 minutes would do. I suppose an hour would do. You know, it needs stirring, obviously. Now, I guess what I could do with this one, I've put the same amount of graphite in there. Now we got a very low reading, 0.4 of an ohm, was as good as the graphite. So, should I put a bit more in and try it? Why not? Let's have a look. I don't want to go too far because it won't stir on the stirrer. So there we go. What I've got now there is 1 spoon of the plastic and a spoon and a 1/4 of the graphite. Not very scientific, I know, but who cares? It works. And just to prove the point, there it is, still stirring away. Okay, so what I'm going to do now is cover that one back up and put the elastic band on it. Now that's quite merrily stirring away there. So really that's it in a nutshell. It's quite an interesting material. Now obviously, if you think about the amount of polystyrene that goes into landfill and places like that, or into an incinerator, it's a shameful waste really, because it can be recycled, and that is being recycled into a plastic, and it's quite a good plastic. You know, I've used that plastic for quite a few things, and as I say, I've made conductive plastics from it. At the moment I'm trying to make that porous for a specific reason. As I said, I'm working with other plastics as well. It's not just this. You know, for my anode and cathode work, composites. There's a lot more material in them than, you know, just a plastic and a graphite or a graphene or whatever. There's lots of other stuff in there. But I mean, I'm not going to go into that in this video. There's no point until I've got some meaningful results and I can show another use I've got for the plastic itself, the porous plastic. I've made porous plastic, you know, but haven't made it as good as I want it. It's not as porous as I want it to be. So there's a bit more research and a bit more work to do. And as I say, as soon as I got some results on that, I'll show that as well. So there you go. A very, very low resistance. Conductive plastic. And a plug for Langage Farm. Okay, one of the uses that I use this material for was to make up some reptile heat mats for my son. He's got reptiles, and it's quite successful. But of course, you've got to vary the amount of graphite in the binder to vary your resistance, and the more you put in, the lower the resistance. The less you put in, the higher the resistance. Now this here is a piece of a reptile heat mat that's on the market. They've been out there for years. Looking at that, I would think that's a carbon black of some sort. It's definitely not graphite, I know that, or even a graphene. Now I've got the resistance meter set on 20k, and if I put the probe on the copper strips, we get a reading of 4k. So, you know, that's where you would want to be roughly in resistance terms to put your mains voltage through that, and that's what they do. Obviously there are heat mats that are not controlled, and there are heat mats that are controlled, where you control the temperatures with a thermostat and whatever, but that's in the reptile world. This particular one, as I say, it's a 230 volt model, as you can see, and the resistance is 4k. So it depends on what you want to produce this material for at the end of the day, and it's just so simple to experiment with it and put less graphite in it to get higher resistances. You don't have to use graphite. You could use carbon black, or, well, just about any of the other conductive materials that are out there. You could use activated carbon if you wanted to, I guess. I've never tried it, but I guess you could. So there you go, any conductive material. But this, obviously these tests were conducted with graphite, so I'm hoping this one has been short and informative. Speak soon. There is one thing I should point out. I did say that I've used this material for making heat mats for my son. I don't mean this plastic material, I mean the graphite when I say that. I use sodium silicate water glass, if you like, as a nice heat resistant binder, because these things are static as well. There's no flexing to them when they're underneath a vivarium or whatever. So yeah, sodium silicate is what I used as the general heat resistive binder. So there you go. You see, now here's me wishing that I'd have actually used my own advice that I gave you. Don't use a beaker, start with a jar that you don't particularly care about, obviously. I'm literally having to use a utility knife to get this stuff off. Now it's coming off relatively easy, but had that been on there for 24 hours or more, it would not be that easy. So I didn't even follow my own advice. I just thought I'd chuck that one in. It really is a hard job now to get this thing clean, especially down in the bottom there. I mean, I'm using acetone as a less expensive solvent, really. So, and it's quite difficult to get in there and do this. So there you go.